So, yesterday we have seen one concept of polymorphism, uh, that is the concept of object-oriented programming. So today we'll proceed further in that direction, and we will discuss some more concepts of the object-oriented programming in terms of Java. Uh, as we know, there are so many programming languages are available that supports object-oriented programming. So the concept implementation varies language to language. So we'll see that how to implement the concepts. And yesterday we have seen one concept, that is polymorphism, object-oriented programming concept, polymorphism. And to achieve it, uh, we perform these operations. Method and constructor overloading, and second one is method overriding. To do compile time polymorphism, we do this method and constructor overloading, and for runtime polymorphism, we perform method overriding. And yesterday, as I told you, that if you want to perform the method overriding, then one condition is required, that there must be two classes and they have the relation of parent child, superclass and subclass, you can say. And you can say inheritance. So first of all, we'll see what is inheritance, then we'll move to the runtime polymorphism. It will make more clear to you. So let's see that what is inheritance. So inheritance means if I say in one line, so I can say that creating or defining a new class with the help of existing class. Okay, so, and this is called inheritance. So this is one of the key concept of object-oriented programming. And inheritance establishes a hierarchical relationship among classes. Hierarchical relationship means, let's see, I'll open the whiteboard. So inheritance means if you have defined a class, that is, for example, test, and you class you define a new class with the help of this test class, that uh, obviously this class will have some feature, and you want that these those feature should be by default available into new class, so you will use inheritance. So it will establish hierarchical relationship. So in that case, we'll say this will be your parent class and this will be your child class. To do this, uh, Java gives you one keyword that is called extends. So only you need to do is, if you want that this class should be parent of this new class definition, then you will write only extends. Extends keyword is available, and extends, and the class that you want to extend means the feature that you want to extend into new class definition. So now this is called inheritance, and this will create a hierarchical relationship. We say that test is the parent class of new class, and uh, there are so many terminologies that we use to define it, like we say the test is the parent class, new class is child class, or we can say it is the super class and in that case we say that this is the subclass, or we say it is a base class. There are so many terminologies. So parent class, superclass, base class, and we say that this is the derived class. So if you follow any book or uh, any tutorial, so if you find any name that is parent class, superclass, base class, then you will understand that this is the parent of any derived class like child class, subclass, and derived class. So all these are same as parent class, superclass, and base class. All are same. To do inheritance, only one thing is required, that whenever you define a class, new class, you will only write extends and then the class that you want to inherit. This is the way that we implement inheritance in Java. Now come to point. So establishes a superclass subclass relationship, and this is very important. This is called establishes is a relationship. Okay, so is a relationship, why we say that it establishes is a relationship, because uh, if I define a class like animal, okay, and animal can be of any one of animal, we can say that dog. So in programming, just understand this point. In programming, the computer knows only, and your system knows that this is one class and this is another class. And we say to the computer that this class consists the feature, the attributes of the animal. So if any class you want to make as animal, then that class must consist these features that we have defined into it. So if we want to define a new class dog and we want to make it as animal, and it should have the feature, the attributes of animal, then we write extends animal. So in this scenario, what we say that dog is a type of animal. Okay, dog is a type of animal because it extends the feature of animal. So this establish is a relationship. Okay, and uh, if you want to create any number of class that should consist the feature of animal, then only you need to write extends. So establishes is a relationship. What is the benefit of inheritance in the programming? The most important feature is reusability of code. Okay, so what does it mean that how do we reuse the predefined code? As I said earlier, if you have defined a class and you create a new class with the help of existing class, so the feature of this class will be available into it. So you don't need to write the code that you have already written. So you will use that written code. So this makes the reusability of code, and as in the second point you can see, put code in one class, use it in all the subclasses. So you can create as many as number of subclasses of class. So that's why it is mentioned here that use it in all the subclasses. And this point will clear when we will move further into the example, that write general purpose code designed for the super type. Okay, so generalized form will be designed and written into the super class, super type that works for all subtype, and it will be available into all subclasses. Inheritance is implemented in Java using extends keyword. For example, the class A is here and you have defined the variables and the methods, and you want that this class should be extended into the B. You will write B extends A, and graphically we represent like this. So B is now subtype, subclass, and A is your superclass. A superclass defines a general set of the functionality, whereas subclasses defines functionality specific to them. So we'll take the example of the animal over here. So we can define a generalized definition for all animals. For example, if I say that, as we know, animal can also talk, and this has been proven already. We have already seen the discovery channels in which we can see that animals can talk to each other. But we know that every animal talks in its manner. So we will define the generalized form over here that animal can talk, but in what way the dog talk will define over here. That will be specific. So this point says a superclass defines a general set of the functionalities where the subclass define the functionalities specific to them. And we can say that cat extends animal, then cat will become animal. Now cat also talk and dog can also talk. But the specific feature of the cat can be defined over here, and the specific features of the dog can be defined over here. But the generalized will be available into the animal that will be common for all subclasses. In other sense, inheritance in Java builds a hierarchy of the classes and thus support the concept of the classification. So this is called the concept of the classification, in which we define the super and subclass hierarchy. These three points are very important in terms of the inheritance. So before moving to this point, I will show you a very small example that how to do this with the within the code. So let's open the notepad. So I'm going to create now today a new fresh copy of the code. So I will write class, and to make clear that one class is the parent and second one is the child, I will write the first class as the parent definition. Okay. And now I'm going to define another class as child class, but these two classes are simple now classes, not having any parent-child relationship. So we'll establish the parent-child relationship by using extends keyword. So first I'm going to save it, and here I'll save it with the name of inheritance demo dot java. Save. So these two classes are two different classes. I want to establish the relationship. Then I will write extends and parent. Okay, I'll make the capital P, parent. And I'm going to define one feature of the parent is it can show something. System.out.println. I'm going to show you a message that is I am show from parent. And since we are extending this class, so this will be available into this class. So you can use this feature by using the child's object, and child can have its own features also it can add it. So I'm going to write one more method into child, that is display. So in this case, child will have two methods. One is called show, that comes from the parent because we are extending, and we extend the parent, and display, that is specific to the child class. Now class, I'm going to write inheritance demo over here, and here I'm going to write public static void main string args, and here we can create the object of the parent as well as we can create the object of the child class, and we know that signature of creation, the syntax, how to create the object. So I will write child reference is equal new child class constructor, and after that I'm going to call the methods, the behavior, the show, and ch dot display. Let's see that this works fine or not. So containing will open into the folder. Now I will compile it first. So I will write Java C, and this is the source file name. After that, okay, from here, before going to execute it, just tell me from this, how many byte code will be generated? Yes, tell me that how many byte code will be generated. If I compile it, then after compilation, we get the byte code. So how many byte codes will be generated after compilation? Are you getting my question?
Yes.
Okay, my question is, Meng, this is the source code. Is it visible to you, Meng? Okay, so just tell me that how many byte code will generate after compilation process, because as you can see, I have compiled it. Yes. So just tell me that how many. Okay, Hinduja says 1 byte code. Good, fine. Then, okay, sure. This one. Okay, 1. Good, fine. And what about Justin? Justin says 1. Okay. So note down this point. This should be clear. Okay. And what will be the name of that byte code that will be generated after compilation? Because that will be your class file. So it will have some name after compilation. So what will be the name of that generated byte code? Main class name, that is inheritance demo. Okay, fine, Hinduja. Then, okay, inheritance demo, name says, and Justin, your answer is same? Okay, good. So I want to show you something, and if you are making a note, then just look at here. So first of all, I'll delete all the class files that have been already generated in my system to make clear. Yes. Okay, fine. Now look at the screen. I hope it is visible. So as you can see there, there is no class file, any class file. Fine. I'm going to recompile the code and we'll see that how many class file will be generated. So Java C and then inheritance demo.java. This is my source file and I'll hit the enter. Now it has been compiled successfully as we are not getting any error. Now come back to the containing folder and see that how many class is generated. One is child.class, as you can see. Second one is inheritance demo.class. And third one is parent.class. So how many class now? 3. I hope this makes clear to everyone that if you define as many as number of the classes in a source file, after compilation, every class will be generated as a separate byte code. I hope this is clear. Fine. Because after compilation, the Java compiler generates byte code for every class. Now, tell me that which class can be run direct from here. So in that case, only those classes can be executed directly by the JVM, which has the main method. So inheritance demo has a main method. That's why this class can be passed direct to the JVM. And when I'll pass it, then we'll see the output. I am show from the parent. I am display from, okay, so sorry, it is the copy paste. That's why we are getting the same output. Okay, one more time. I'll compile and then execute. I'm show from the parent and I'm display from the child. I hope this execution is clear. What if I, since, look at this, child is another byte code and parent is another byte code, inheritance demo is one of another byte code. So a JVM executes the byte code. So we can pass the byte code to the JVM as I can write parent class, but it will show you error because in parent class, we are not defining any main method. So the execution of the class starts from the main. That's why we are getting error. So to pass any class to the JVM, first make sure that that class has main method. So in particular example, as we can see, inheritance demo has main method. That's why we can pass inheritance demo to JVM to execute. And since this will execute in your JVM, so it will create an object of the child class. After that, we can call the methods that is available into the child class. So in child class, show comes from the parent and display is its own feature. So child class having actually two methods. One is from the parent and second one is from its own. Now tell me, this simple example is clear? This is a very basic example of inheritance. Okay. And this type of the coding is standard that in a single source file, if we define more than one class, so this coding convention is not preferable and not appreciable. The Java says for every class definition, we should write and we should create a separate source file. Okay, so we should write the parent class definition into the separate source file. We should write the child class into the separate source file, and we should write this inheritance demo into the separate source file. Java's standard says this should be followed, but we can write, and to learning, I am writing this type of the code. So this is not the standard of the coding. So don't make it in habit. Now, how many types of the inheritance Java supports? Okay, so there are, if you have already learned C++, as you said in the very first session. So C++ also supports types of the inheritance. So let's see that how many types of the inheritance supported by the Java. So I will write types of inheritance. First one is called single inheritance. Single inheritance. This one. Please mute your mic. So a single inheritance means if one class extends the another class. Okay, so if one class extends the another class, for example, if there is a class A, and if you define class B and you write only extends A, so this is called the single inheritance. One class extends the another one class. Second is called, that we say, hierarchical. Hierarchical inheritance means if you have a class, this, look at the, you can correct your spelling, that is the hierarchical. Just understand it. What is the hierarchical inheritance? That is, if we have a class A and if we define a class B that extends A, and another class if we define, for example, that is C, and it extends the class A. So this type of the inheritance is called hierarchical inheritance. So in definition, we say that if one class has more than one child, okay, so one parent, more than one child. So this is called hierarchical. So as you can see, class A having two child, that is B and C. Single inheritance means one parent, one child. As you can see, one parent and one child. And third one is, the third type is multi-level inheritance. Okay, so in this inheritance, if you have a class A and if you define another class B which extends A, and further if you define class C that extends B. So in this case, as you can see, A is the parent of B and B is now parent of C. So if one child becomes the parent of another class, in that case, we say that this is the multi-level inheritance. So in this, what will happen? The feature of the A will available to the B, and the feature of the B will be available to C. So indirectly, the feature of the A will be available to C. And we can read it as B is the parent of C and A is the grandparent of the C. Okay, and A is the parent of B. So this is the multi-level inheritance. And in terms of the class, noted in class, the multiple inheritance is not supported by the Java. Inheritance, that is multiple means if you create a child that has more than one parent, so this multiple inheritance is not available in terms of the Java. Multiple inheritance is not supported by the Java. So these are the types of inheritance that is supported by your Java. I hope these inheritance type is clear. Yes, tell me. Okay, good. Now, again, come to the example, and one by one we'll see the example of inheritance. So this is called single inheritance. This is called single inheritance. Fine. One parent, one child. Now come to hierarchical. Hierarchical inheritance means one parent having multiple child. So if I define another class that is child 1, and I will write another child, extends the parent. So this is the hierarchical inheritance. One parent having more than one child. This is the way. And multi-level inheritance, here we'll write like this. So this will make the multi-level inheritance in Java. And the note is, the keynote to inherit any class is, we cannot write, just listen this point and remember this point, we cannot write more than one class name with the extends keyword. Okay, as we can see, class child extends one class name, another child extends one class name. So if you write more than one class name over here, so this will raise an error because Java does not support multiple inheritance. So in terms of the class, Java does not support multiple inheritance. So if anyone asks that the Java supports multiple inheritance, so the straightforward answer is no. Now come to the points. which members you cannot inherit into the child class. So these members cannot be inherited into the child class. One is private members of the superclass are not inherited by the subclass and can only be indirectly accessed. Indirectly accessed means with the help of any method. So we can access, but directly private members cannot be accessed and it won't be inherited. As we know that the private members accessibility is limited to the class, so private members cannot be inherited into the child. Second, constructors and initializer blocks are not inherited by the subclass. So in inheritance, the constructor of the parent and the initializer blocks that you have defined into the parent class will not inherit into your child class. So these 2 points, uh, just remember, because this is the concept. I'll delete it. So if I define the method as a private void show, and if I will try to access ch.show, so this will show me error. So Java inheritance demo.java. So error cannot find symbol, as you can see, ch.show, because the show is private. So private member cannot be inherited. And if you define any initializer blocks may be your static initializer blocks and non-static initializer blocks. So these will not inherit into child. The point says the private members of the superclass are not inherited by the subclass and can only be indirectly accessed. So what does it mean that how we can access the indirectly? For example, if I define a method, a variable, private int a is equal 10, and I want to access this a into this child. Okay. So what will I do? I will make a method that can be inherited by the child, that can be available into the child, and from this method I can access this a. So I can write like this, return a. So it will return the value of a, and here I will write like this. Now this show will be available into the child class, and from this show we can access this private member. So this is the way that you can access the private members outside of the class through the child or without the child. I hope this point is also clear. Now come to the third point, this one. Yeah, it's a recording. Okay. So this third point is important. That is, when you construct an object of the base class, the default base class constructor is called implicitly before the body of the derived class constructor is executed. This point is important, and to understand it, we'll define constructors and we'll see the object creation hierarchy, at which manner in which manner the object gets created. So I will not write any member into any class. I will just define the constructors. So this is the parent. Look at here. I will define the child class constructor. Child, this child, and this one, and system dot out dot println, and we can say that this constructor is the default constructor on non-parameterized. So I will write only the default constructor of child. Fine. And create an object of it. copy and paste into the parent, copy, paste, and this one. To make clear of that point, when you construct, the point says, when you construct a child class object or derived class object, look at here, we are creating the object of the derived class. The parent class default constructor gets executed automatically, implicitly. You don't need to call, okay? Before the execution of the child class constructors. So if I execute it, then you will find that first the parent default constructor gets executed. After that, this will be executed. So look at the definition and execution. As you can see, default constructor of the parents execute, default constructor of the child after that. So this is the third point, which says when you construct an object of the derived class, the default base class constructor is called implicitly. So every time the parent's default constructor will be get executed before the body of the derived class constructor is executed. So objects are constructed in top down under the inheritance. So it means first it will be initiated, and after that your child will be initiated. Okay, and as we know, without parent, child cannot be in existence. So Java follows the same rule. Okay, so first of all, the parent will be in existence. After that, child will be in existence. So first parent's object will be created. After that, child's object will be created in inheritance in Java. Clear? Okay. What if I have a constructor that is, because we can overload the constructor, as we have seen yesterday. Constructor overloading is also we can perform the polymorphism. So we can write the child integer a. So this is the constructor that is available into the child. So when you create the child object, of course you will pass an integer value. Fine. And when you will run it, this will execute perfect. So no problem at all. So in the same way, we can overload the method, or we can define a new constructor into the parent, that is integer a. Okay, so now this is the constructor that is available into the parent. Now, if we will compile this code, then we will get error. Look at here. The constructor parent in class parent cannot be applied to given type child integer a. Why? Because required integer and we are found no arguments. Why? Because the rule says, come to the third point. Again, rule says when you construct the derived class object, base class constructor is called implicitly. Which constructor? Default constructor. So every time when you create an object of the child class, first of all, it will execute or call the default base class constructor. And as we can see, there is no default base class constructor into it. So that's why we are getting error. It means we can resolve this by, we have to create a default constructor in it, then it will be fine. Look at here. Now it becomes fine, because when you call it, it will call the default base class constructor. Clear? So implicitly, every time when you create an object of the child class, the parent's default constructor will be called. So if you don't have the default constructor, so one solution is create a default constructor into it. This is clear? Now, what if we don't want to create a default constructor? And I want that the default constructor should not be execute. My this constructor should be execute. So there are two conditions. One is I want to make change that the every time implicitly the default constructor gets executed. I don't want to execute the default constructor. I want to execute my this constructor when I will execute any child class object. So in that case, what you will do in the child class constructor, you will write the super represents the parent's object. Okay, base class object. So super and the constructor that you want to execute pass the parameters. So I want to execute this one. So I will write 1 or 2 anything. Okay. So now look at the compilation. We will not get any error because we made the changes into the default behavior. What is the default behavior? Default behavior is when you create any object of the child class, parents class default constructor gets executed, but we make the changes that no, I want that the parents class, this constructor should be execute. So we will write super and the parameter that matches. So this constructor will call. Now, okay. So constructor of the parent and constructor of the child. So I hope this also gets clear that if you want to make changes the behavior, then this is the way. Or if you want that no, the default should be executed every time, then you need to write the default constructor of the parent. So this is applicable for every parent-child relation. This is applicable for every parent-child relation. And from here, one important note. This super that you write into the child in which you pass some argument to call the parent's constructor. One more time. The super you write in which you pass the argument to match the parent's class constructor argument must be very first statement into the child class constructor. Are you getting my point? Or one more time. Okay, fine, Indra. So Justin and Meng, this point is clear? One more. Okay. Listen very carefully. The super that you write into the child class constructor that matches with the parameter of the parent's constructor must be very first statement into child class constructor. Suppose if you write it over here, super and 20, fine. And if I delete it, so now look at the compilation. Again, we are getting error. And call to super must be first statement in constructor. This is the note. This is the point. I hope you all will remember this point. Two question comes from this point into any online test. So super and 20. So if you want that, then this must be very first statement. I hope this point is also clear to all of you. Meg, now it is clear. Yes, this is also possible that a child cannot have a constructor, but the situation you have to analyze, Ming. Okay, your question is that suppose the parent has a constructor, for example, this one, and child doesn't have this one, Ming. Okay, now tell me. So your question is if parent has the constructor but child not have, isn't it? Yes. So I'm teaching you the concepts. Okay. So now analyze the concept that you have learned, that whenever you create an object of the child class, so we'll write this statement to create this statement. Fine. Before execution of the child class constructor, by default, the parent's default constructor called. Fine. So in this coding scenario, is it possible? No. Why? Because this is the default constructor, but this default constructor will be available by your compiler to the generated bytecode that we have already seen yesterday. If you don't mention any constructor into your definition, the compiler will add a default constructor. But in that case, the super will be not added into the default constructor of the child. So in that case, you will get error. Look at here. So actual and formal argument list differ in the length, as you can see. So that's why we will get error. So you all have to analyze that the concept that is provided by the Java is properly applicable in your code or not. So in this scenario, that concepts are not applicable. So what we have to do in this case scenario, I'm writing, I need to create a constructor first of all, and in that we have to write this one. Now this will make your code executable. Look at here. Fine. Meng, okay, did you get your answer? Okay, fine, Meng. So I hope this concept is clear to everyone, that parent-child relationship and the member that you can call and which member you can execute and which member cannot be inherited, and how you will call the members. I hope this is also clear to everyone. Fine. Okay, now tell me, do you know the concept of uh, upcasting and downcasting? There are two things. Okay, upcasting, Meng says no. And Justin and Hinduja, do you know the concept of upcasting and downcasting? So actually, what happened? Few times we get confused in two terms. So I'm going to make clear of it. There are two terms. I hope you must aware with this term, that is typecasting. If you want to convert one type to another type, that is called typecasting. For example, if you want to change the float value into the integer, so we perform the typecasting. Fine. So I'm talking about upcasting and downcasting. Fine. So let's see what is upcasting. Upcasting means when we point a child's object through the parent reference. So parent reference points to the child's object. This is called upcasting. So how do we do this? We write parent class name, parent class name. One reference is equal new child class constructor. This one. This is the signature of upcasting. So did you get this signature? This is called upcasting. And it is very useful in programming. It is very useful. And whenever you will go into the actual coding part, then you will find everywhere this type of the syntax is written. So you, whenever you see that, since till now we have learned that if we want to create object of any class, look at here. In this case, if we want to create an object of the child class, then we write child, then a reference of the child of the class, and then constructor. If we have the parent and child relationship, then parent's reference can point to the child object. This is called upcasting. Okay. This is called upcasting. What happen if we do this into the code? What will happen if we do this into the code? So we have already cleared the concept of calling the constructors. So I will delete the constructors. So make code more clearly. Now, earlier we defined, as we have already seen, one method is show into it. System.out.println, and I will write show from parent. This is the output. I'll make copy and paste one more method, that is the display, and I will change display from child class. Okay, I hope this is visible to everyone, and very simple definition. Class, methods, one class extends the parent, define its own behavior, that is display, and one comes from parent, that is show. It means child having two feature, one is show and second one is your display. So when we perform the upcasting, it says using this reference, we can access, listen this point, we can access only those member of the class, because the object is the child. Remember this point. We are not creating the object of the parent. So this will point to the object of the child. So this object will encapsulate all the members of the child class. Got it? This object will have encapsulate all the members of the child class. And in child class, we have two members, that is show and display. So can we call all the members? P dot show, can we call it? P dot display, can we call it? So we'll see with the execution, then I will make the statement. As you can see, the display method cannot find a symbol, but show can be accessed. So this says if we make upcasting, then only those methods can be accessed through the reference which are inherited into the child class, which are inherited into the child class from the parent, but the child's specific member cannot be accessed through this parent. Clear? We can access only those members of the class of the child which are inherited from the parent, or which are overridden into child class. Overriding we haven't completed it, but which are overridden into the child class, but the child's specific method cannot be accessed through this reference. Clear? Okay. So this is called, actually, one more term we use to it, that is called dynamic polymorphism. We say this is also a term that is called dynamic polymorphism. This term, just note somewhere when I will explain the abstract class. Okay, just remind me that, sir, please tell me that one example of the dynamic polymorphism. So this will make more clear to you that why do we use this type of the signature in the coding. And this is very useful, and you all will use this signature, this statement very frequently in your actual coding implementation. So that's why I'm saying so many times. So this will show error. So I'll make this as comment. Now if I compile and run, then you can see show from the parent, it has been accessed. Now, what if I want to access display? Okay, what if I want to access the display of this object? So before going to this, okay, I'll make some diagram over here. So this will make more clarity to you. As we know, objects gets created into heap, and heap is denoted by some zigzag line because it is not fixed. As we put the objects, it gets increases its size, and stack is here, as we have already seen this. So I will create one more time, that is a stack and heap. A stack, and this is your heap memory area. So as we know, objects gets created into the heap and reference gets created into the stack. So I will create the reference over here, that is P, and object I will create over here, and it will have the members, actually two members. One is show and second one is display, and this reference will point to this object, as we have already seen this. Just look at the syntax, parent p is equal new child. So object of the child will create into the heap. It will have show and display. One come from the parent, and second is the child's its own behavior. Now p cannot access this display because parent, for the parent, this is not visible. So p can access the show, as we have already seen with the example that show has been called. What if I want to call this display, because the display is encapsulated into the child's object? Okay, are you getting my question? I want to call this display. As we can see, the display is encapsulated into this object. So what will we do? We can do two things. One, we can create the child's new object over here. Now we can write ch.display. You can say this statement. This is fine. You can call it. But I want that the new object should not be created. The object that is pointed by the parent reference should be called. So in that case, what will we do? We perform the downcasting. So we'll downcast this parent reference to the child by writing the signature in which I will downcast this P into the child, this one. So now, as you can see, only new child is written one time. So this whole statement will create only one object. Now P is now downcast to the child. Now ch can call display. Look at the coding, as you can see. So this term is called downcasting. This term is called downcasting. This one. Clear? This term is called downcasting. So come to the note over here. So upcasting and downcasting. So in downcasting, what we do, we write child class name over here. One reference is equal the child class name into bracket and reference of the parent. Reference of parent, parent. I will make whole statement. Reference of the parent that points to the child object. I hope this statement make more clear to you. Reference of the parent that points to the child's object. As you can see, come to the code. Where is this? Yes, this one. Child class name, reference, then we write. Are you getting my voice? Because I'm getting a message that. Are you getting my voice? Yes, hello. Okay. Now it's still breaking. Okay, fine. So just come to the syntax and the code. The syntax I have mentioned over here, that is child class name, reference, the child class name, and the reference of the parent that points to the child object. So come to the code, child class name, reference, child class name, and the reference that points to the child object. The P is pointing to the child's object. So this is called downcasting. Fine. I hope this statement is clear. So this is all about related to the inheritance, because inheritance is only the concept by extending a class into another class, and there are so many things that is behind the scene. One is your upcasting, downcasting, and dynamic polymorphism, and which member you can access, which member you cannot access. So these are the things that is very important to understand. So I hope this inheritance is clear to all of you, and this third point is also clear to all of you. So this is the example that is mentioned here: method overriding. So what is method overriding? Method overriding means inheritance. After inheritance, we can perform the overriding if we required them. It is not mandatory that every time you will override. But what is method override all about? Just understand, it is very small uh, concept, and but in use it is very important. So when a method in a subclass has the same name and the type signature as the method in its superclass, then the method in the subclass is set to override the method of the superclass. Okay, so what is mean by this point? For example, parent, I have a class that is parent, and this method is available into the child class. So if we define a method, say with the same signature as into the parent, so now this method is called overridden method. Okay. Uh, Visible? Is it visible? Okay. So if you have the method that is that has the same signature as the parent has, so this is called overridden uh, method. And what we do, suppose this comes from the parent as show from the parent, but I want that this method should have some other definition. I don't want to use as this one. So we can change the definition of this method by writing our own. So now show from the child. Fine. So rule says, or in the programming term, we can say, if we redefine the parent's method into the child class, that is called overriding. If we redefine the parent's method into the child class, that is overriding. So here we can see we are redefining the show method into child class. So this is called overriding. Now come to this part of the code. Parent P is equal to new child, and as I said, this reference can access only those methods which are inherited into the child or which are overridden. So in this case, now show is overridden into the child class. So when you will access the show, it will access this definition, not of the parents, because the object is created from the child class. Okay. Okay. Still it's breaking. I hope for now it is clear. Okay, let me check. Okay, now okay. So as you can see, when I execute this code, I'm getting the message that show from the child. It means the method of the child class gets execute over here. Parent p is equal to new child p dot show. So when you override, then this reference will call. Getting my voice? No voice? Hello. Okay. Okay, fine. So as I said, this is the way that you override it. Now come to some points that at the time of overriding, what you can make changes in the overridden method. Now come to this point. First thing, that is only non-static can be overridden. A static method cannot be override. Just make clear noted. Both the signature and the return type must be same as the super type. As in one line, I said to you that if the parents method redefined into the child class is called, if we redefine the parents method into the child class, so that is called method overriding. And suppose if we have some access modifier over here, for example, in this case we have the default access modifier of it, as we have already seen into the previous session, that if we don't mention any access modifier, then it is by default. So can we change the access modifier when we override the method? So answer is yes, we can change the access modifiers of overridden method, but the condition is you can change the access modifier only and only if you provide the more accessibility to the overridden method. You can change the access modifiers of the overridden method if and only if you provide more accessibility to the method. Fine. So this method having the accessibility default, so we can provide this as protected, because protected has more accessibility than the default. Now come to the compilation. So there is no error. Fine. Or what we can write? We can write the public, because public has the more accessibility than the default. Now come to compilation. As you can see, there is no error. But what if I write the private? Private has the less accessibility than default, so the weaker accessibility we cannot provide to the overridden method. As you can see, attempting to assign the weaker access privileges. Okay, so that's why we cannot override this method. In the same way, if this method has the public accessibility access modifier, and if we are providing, since we are not mentioning over here any access modifier, so it is by default default. And in this case, if we compile it, so again we are attempting to assign weaker access privileges. It was public, but we are assigning as default. Okay. When you override a method, so we can change the access modifier accessibility of the method at the time of overriding. Fine, Hinduja? Are you getting my voice? Yes. Okay. So if you want to assign accessibility to overridden method, then make sure that you are providing more accessibility or the same accessibility. So as you can see in the parent, this has the public access modifier, but when I am overriding this method, I'm providing the default. And yesterday we have already seen that the default has less accessibility than the public. So you cannot provide the weaker accessibility to the overridden method. This is all about uh, the access modifier change if you override any method. So as you can see here, when I was compiling it, it shows me an error that attempting to assign weaker access privileges in the parent class, it was public, but in the child class, I am providing it as default. So I'm going to conclude it. That is what is in overriding. Overriding means the parent's method, if you redefine into the child class, it is called overriding. So the return type and the signature of the method must be same, and you can change the accessibility of the overridden method, but by providing more accessibility. If you want to make changes, then you can change, but by providing more accessibility, not less accessibility. So these are some points. A subclass can change the access specifier of the method of the superclass, but only if it provides more accessibility. A method declared protected in the superclass, if we have a method in the superclass that has the accessibility protected, can be redeclared protected or public, but not private. Fields cannot be override, they can only be hidden. And to access the hidden fields, we use the super keyword. So fields, as yesterday I told you, method overriding concept, and to access the hidden fields, we use super keyword. So I hope these 2 points are clear to all of you, and we'll see this with the help of the example. So how to access the hidden fields with the super keyword, but not today. We'll see it tomorrow. So super we'll discuss tomorrow, and for today, this method overriding and inheritance. I hope all the concepts are now clear to all of you, that how to inherit and how to override method. Now tell me, any confusion related to the inheritance and method overriding? Yes. Any question related to the today's topic? Okay, fine. In the chat. Thank you. Justin, good. Ming, yes. If you have any query, then you can put your query into chat box, and then. Okay, I'm not getting input from the Ming. Can you hear me? So I will try to make available this video very soon to all of you. If you miss any concept, any thing, then you can refer to this video. So Ming is not responding right now. So thank you. Thank you for joining this session. And tomorrow we will start from here, that how to use super, and after that few more concepts. Okay. Yes, Ming. I was asking, is there any question that you want to ask? Okay, so tomorrow we'll see with some more topics. And when you come to join this session, make sure that you have revised all the concepts. Thank you for joining this session. Thank you. Bye-bye.